Alrighty then, here we go. Last example, last one I have. All right, example number 10 is a graph, and we're asked to find the x-intercepts. The x-intercepts. Now, if you don't know what x-intercepts are also known as the zeros of a function. All right, and when you find zeros, you find solutions to equations. All right, solutions. All right, to equations. And why is that? Well, because essentially that's where you set it equal to 0, all right? So x-intercepts are zeros of a function. Sometimes they're known as solutions to equations. Sometimes they're known as roots, all right? Okay, a whole bunch of different things can allow you to find these different things. But x-intercepts are essentially when the y value equals 0. So in this case, we're going to set this equal to 0, and we're trying to figure out when is sine of pi x plus cosine of pi x, all right, equals 0. Now, to do this, I don't really look at pi. So we can get the pi's right here. We're going to use this to solve, and we're going to look at this graph right here, and we're going to look at the one where we have, notice where our zeros are. So we have one here, 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 and here. All right, so we're going to have 4 different solutions that we're looking for. Now, in order to figure this out, what we're going to kind of think about, and how I would think about is if I would take this, I would actually subtract one of these values to their side. So I would go take, or what we have to say is that one with sine and cosine add together and equal to 0. Well, the only time, if you know anything about trig, the only time sine and cosine are actually equal. When are sine of x and cosine of x ever equal? All right, well, they're ever equal is going to be at pi over 4, or 45 degrees. That's the only time they are ever going to equal. And any multiple of pi over 4, 45 degrees, well, we're in the first quadrant, okay? So if you think about that, now, the thing is that sine and cosine can't be equal because if I subtract this other side, actually we have negative sine, and there's going to be a pi here, all right? And there's going to be another one right there, all right? So essentially, when are they opposites? So not when they're equal, all right? So essentially, when are they going to be opposites? So they can't be right here. So I'm going to erase that. When are they opposite? Now, let's think about this. So essentially, they have the same angle, so 45 degrees when they're equal, but they're opposite. Well, first quadrant, sine and cosine, all right, for x equaling pi over 4, all right, they will be equal, okay? These are going to be equal, all right? Oops, it should be cosine of x. They're going to be equal. What else are they equal? Well, over here in the third quadrant, all right, the third quadrant, yes, sine of x, because if you look here, x is negative here, y is negative, and over here, all right, y is negative, and x is positive, all right, y is positive, I'm sorry, and y is negative right there, yeah, all right, golly gee willikers, all right, so we have that right there. So the third quadrant, sine of x, is also going to equal cosine of x. So when are they going to be opposite? Well, they're opposite because sine of y, cosine of x. When are they opposite? Well, they're opposites for x or multiple of pi over 4. All right, so when x equals, that would be 5 pi over 4. All right, would be in the third, or sorry, the second, and the fourth quadrant. Here, right there, they're going to be opposites, okay, right? They're going to be opposite here, and this one's going to be opposite right there, okay? And that's when they're going to be opposites, and that's what we have right there. So we're really looking for when they're going to be opposites from each other, because this could be negative sine, but this will be positive sine, so on and so forth. All right, so I could easily just switch this around. So essentially, we're looking for angles here in the second quadrant and also the fourth quadrant. Those are the values where they're going to be opposites. And that's what you kind of think about. Now, this is a harder problem, all right, because that's when they're going to equal 0. So, for example, if I put in, all right, if I had sine in the second quadrant, that would be a multiple of this would be when x equals, all right, 3 pi over 4. All right, so if I put in 3 pi over 4 for sine, all right, 3 pi over 4 for sine would be positive. All right, that would be positive. All right, and over here, all right, and if I put it in here, it would be negative cosine. All right, if I plug that in there, okay? and in there. All right. Now on here, it would be the opposite because cosine, if I plugged in this one, x is going to equal, what would that be? That would have to be 7 pi over 4, 7 pi over 4. Cosine would be positive now. All right, because that's in the positive because it's when x is positive. And down here, cosine, or sine, that is, sine would have to be negative. All right, sine would have to be negative, and that's horribly drawn. All right, this is a drone. All right, cosine of x positive here, and we have negative sine right there. Okay, so these essentially are our values that we're looking for in there. Now, the thing is that, all right, that would make sense, and that would be cool, all right, for those. Now, the thing is that I also need a negative one. Well, the negative one would be, all right, if I took this and I would go the opposite way, and so essentially if I had x equaling negative pi over 4, that would be another solution. So I got my negative one. All right, I have my first positive one right, my first one right there. My second one, then there has to be another one. So I'm guessing that when we have this, we probably are looking at having another one over here, is that when we go all the way around again, all right, we're going to hit that next one. So we have to add another 2 pi. So we're probably looking at, all right, 3 pi over 4, all right, plus 1 extra 2 pi, okay, plus 1 of the coterminal. Okay, so let's see how this works out. So we found out 1, 2, 3, 4, the 4 values we have. Now, the thing is that that's when sine is just x and cosine x. They're not. They have pi's right here. They have pi's. So our solutions that we found, I'm going to write this out now. Hopefully you're all following along, is we found that when we solve this, we're going to have pi over x for both of these. Okay? And we're going to have one which is going to be 3 pi over 4. If we go in order, I guess we have another one which is going to be another one, pi over x. When we have negative, all right, pi over 4. And we'll have another pi over x when we're at 7 pi over 4. And then we'll have another one right here, all right, pi over x, when we have 3 pi over 4 plus 2 pi. All right, plus 2 pi. But now to figure this final thing out, is we're going to do is, guess what? Just like we did before, we have to divide by pi. So we're going to take each one of these, all right, and we'll multiply by 1 over pi. 1 over pi. Now when we do that, we get some different answers. And so this one's going to actually turn into, when we divide by pi, we have negative 1/4. Oh, cool. That makes sense because that's the first intersection right there. Cool, negative 1/4. That one's going to turn into 3/4, and that totally makes sense because that's exactly where it is, 3/4. Awesome, because remember, 1/2, 3/4, 1. This one's going to turn into 7/4. 7/4. Now 7/4 is going to be 1 and 3/4. Yes, 3/4, perfect. Now this last one, what? Look at this. It's going to be 3/4 plus 2, which would be 2 and 3/4. So 2, and if we have this 1, 2, 2.5, right? All right. So we have 2, 2 1/4. Is that right? Yeah. All right. And we divide that into 2 and 1/2, and then we have 2 and 3/4, and that's where all of our answers are. That's our solution. Pretty cool, huh? So this one's a little harder. All right. We had to find x-intercepts with this is equal to 0. This one was not traditional. We had to use a little bit of trig sense. All right. So we had to figure out when sine and cosine, when they're going to be equal, because essentially they have to be equal when they're opposite. All right. Okay. So in this one, we have to think about, okay, when are they opposite? So it's going to be pi over 4, because that's the only one it is. All right. So you have to know, once again, know your unit circle. All right. Pi over 4, that's when they're going to be equal, but they have to cancel each other out. So that means we have to do the second and fourth quadrant because of the opposites to cancel each other out. And then we look at our graph to figure out, okay, we needed a negative one, we had our first positive one, second positive one, and we needed one more. And so we had to add a coterminal angle, and that's how we got all the different ones. Yeah, this was a hard one. This was really complex. But we found all of our values, and that made me happy. So I'm just going to put a little smiley face right there, and that's happy. All right, so hopefully going through this helped you understand more about trig, helped you understand a little bit more about the unit circle and how we can use these basic trig functions, how to use coterminal again, how to find x-intercepts, and using graphs. All right, well, that's all I got. Hopefully this helps you out a little bit and how to break these problems down. And I'm just going to say good luck and God bless on the rest of your problems.